distribution, if you remember. And what I show you how we can do the trip distribution by manual method. And then I developed the gravity model formula for it. So your gravity model formula was Dij is equal to OI times AJ divided by Cij to the power of B divided by the summation of AJ divided by Cij to the power of B. So this was the gravity model that we developed. Now I'm going to give you an example of how that can be used. Let's assume that we have 4 zones. Okay, so this is zone 1. And then we have zone 2. And then zone 3. And zone 4. So we have these 4 zones. So on zone 1, so this is zone 1, this is zone 2, this is zone 3, this is zone 4. Now on zone 1, there is 1,500 trips that's produced. So, so your OI, or O1 in this case, is 1,500 trips. And so 1,500 people want to go shopping. Let's look at it this way. So we have 1,500 people shopping trips that want to go shopping. And there are 4 shopping centers in each zone. On this first one, the area of that shopping center, which is the A1, is 10,000 square feet. On zone 2, the shopping center is 10,000 square feet. On zone 3, we have shopping center of 15,000 square feet. And on the zone number 4, we have 5,000. Okay. Now, the distance between these zones, first one that goes from 1 to 2 is 10 miles. From 1 to 3, which is C13, that is 5 miles. No, I'm sorry, 3 miles. And from 1 to 4 is 5 miles. So those are the distances between these zones. Now the question is that out of these 1,500 trips that want to go shopping, how many of them would like to go to the first shopping center zone in zone 1? How many people want to go to the second shopping center, which is zone 2? How many wants to go to zone 3? How many want to go to zone 4? So that's the question. So we want to distribute the 1,500 shopping trips among the 4 zones. You want to use the gravity model to do that. So the model that that I wrote on the top. Okay, so everyone understand the problem? Okay, 1,500 people want to go shopping, 4 shopping center available, and we want to know how many will go to shopping center 1, 2, 3, and 4. So we want to distribute the trips. That's the trip distribution, allocation of the trips among zones. Okay, so let's just see if we can use that. So the first one, oh, I see. There is another C11. That means the shopper that want to go to the first shopping center, and that is 1 mile. So this is like this situation. People live here, all these people living here and so on, and there's a shopping center here. So from the center of this center to the shopping center is about 1 mile. Okay, so the first one, we want to know how many people will go to the first shopping center in that zone. So we are looking at the T that start from zone 1 to go to zone 1, T11, equal to, what would be the OI, the number of the trips that's produced in zone 1, which is 1,500. And what would be the AJ? J is your destination zone. Your destination zone is 1 because you're going to the first shopping center. So A1 is what? 10,000 square feet. And that is divided by CIJ. So that will be C11 because you're going from zone 1 to the shopping center 1. So that is 1. And for shopping trips, I told you last time, for a B, we are assuming number 2. So that will be the numerator. What would be the denominator? The denominator is the summation for all J's. So how many J do we have in this problem?
Is it 4?
4. There are 4 shopping centers, 4 destinations, correct? So there are 4 of them. So that means this is going to be the first one, J equal to 1, will be A1, correct? So that will be what? 10,000 square feet divided by C11, because you're assuming J equal to 1. So that will be 1, and then will be squared. So that is the first one. If you're assuming J equal to 2, so that summation will be plus A2. A2 is what? A2 is 10,000 square feet divided by C12, because J is equal to 2. So that is 10 miles squared plus the J equal to 3. So that means A3. So that's 15,000 divided by 3 squared plus, now we have 5,000 for 4. So 5,000 divided by 5 squared. Okay, does everyone understand what we did? So J varies from 1 to 4. So that's what you have to do. This is a section that some students have problem with. So first you have to know how many destinations you have, and then vary J from 1 to N.
Professor,
Yes.
why is it squared? I know that
Okay.
for like the bottom.
Yeah, the reason we have, that's a B.
Right.
Okay, I mentioned last time the B depends on the purpose of the trip. And I said for purpose of the trip is with shopping, we use B equal to 2.
Oh, okay. I remember.
Yeah. All right. Any other question? Okay. So when we calculate that, this will be 1,500 times, okay, 10,000 and divided by 11,967. And that will be equal to 1,253.5 trips. Since we don't have a trip, we can round it off to 1,254. Okay, so which means that out of 1,500 shoppers, 1,253 or 1,254 of them are going to the first shopping center, which is only 1 mile away. Okay, now we want to know how many go to shopping center 2. So we are looking at T12. So we do pretty much the same calculation. It says 1,500, which is your OI. Your AJ is what? Is 10,000 divided by 10 squared, because J equal to 2, C12. The denominator is the same thing, because still you'll have to have that summation. So it will be the same as 11,967. So when you calculate that, you will end up with 12 and a half trips. Per day. And that's understandable because the size of the shopping center in zone 2 is exactly the same as size of the shopping center zone 1. So why somebody wants to go 10 miles away to the same size shopping center? Why you can go within 1 mile of their residence? But still some people go. So it's around 13 people will go, but the number is low. Let's see how many will go to zone 3 or shopping center 3. So you do the same thing, 1,500. Okay, multiply that by 15,000 divided by 3 squared. The denominator will be the same. So you calculate that, that will be 208.9 trips per day. Okay? So 208 people or 209 people will go to the third shopping center because it's only 3 miles away, and the size of that shopping center is 1.5 times the shopping center that they have over there. So that attract more people. And for shopping center 4, which is T14, you have again 1,500 times 5,000 divided by 5 squared over Same thing, 11,967. And that will give you a number which is 25.1 trips per day. So you have 25.1, you have this 12 and a half, and then you have 1253.5. So we distributed the 1,500 trips among the 4 zones or 4 shopping centers. So if I add these together, what do I get?
Should get the 1,500.
Yeah, you get the 1,500. So we distributed the 1,500 among the 4 shopping centers. So when you add them up together, you should have about 1,500. So we use the gravity model to distribute the trips. That's how we do it. Any question on this?
Sorry,
Yeah, go ahead.
what about if you start from 2 instead of 1? Would it be different, or you cannot start from 2?
Well,
They
the
just
2 doesn't have any trip produced.
Oh, so we start with the ones that have the trip produced, and we go
Yeah.
forward. Okay.
So first you have to produce the trip. So there should be people who want to go shopping.
And then from there you go to
So
1.
that is only in zone 1.
Okay, got it. Thank
Zone 1 would be just a residential zone that people go from there. But if there are some residential zone in zone 2, then you have to do 2 to 1, 2 to 2, 2 to 3, 2 to 4, the same way. And figure out how many will go, and then add up those numbers that go to each of those shops. You can have all 4 of them actually, if there are production in all 4. Then you have to do 4 times this, and then you have to add up how many go to each of those shopping centers by each zone. Okay, any question? Any other question?
Professor, I have a quick question about the exponent in the formula.
Yes.
In what cases would it be like more than 2?
Well, the social.
Oh, okay.
The social visit 3. Or if you go shopping and people going to buy convenience goods. What are the convenience goods? Like going and picking up refrigerators or a microwave oven or washer and dryers and things like that. So those shopping centers are less attractive. So the higher the number is, that means the less people will go. For instance, if you want to buy small items like a shirt or a pants and so on, okay, you have a tendency to go to that shopping center more often than if you want to really pick up refrigerator and so on. Not too many people going pick up refrigerator, microwave, and so on. Most of the people going for just a small item shopping. So that B gets to be larger. Now, if you remember, I said B for work trips is a 0.5, half a point. Why is it so low? Because look at it this way, the lower the B gets, the more trips it will go in the formula. When the B is small, the TIJ gets greater. The reason is that if you find a job that's 50 miles away from your house, you definitely need to go. You don't really care about the distance as much because you have a job. So people go to jobs that even 100 miles away every day. You know, that there are people who live in San Diego and work in downtown LA. They commute every day. But if you want to go and visit a friend or a family member, if the distance is too long, you don't have a tendency really to go. You might go, but not really the way you go to work. So for that reason, for work trip, we have a B equal to 0.5. For social visit, we have a B equal to 3. So it all depends on the purpose of the trip.
Okay, got it. Thank you, Professor.
All right. Any other question? For instance, for recreation, we use B equal to 2. And for businesses, we use equal to 2. Shopping, we equal to 2. But for social and then convenience good, we use B equal to 3. And then for work trip, we use B equal to 0.5.
Professor, are these numbers in the book?
No, actually, this portion is not in your book. Okay, this is a original portion of it. And then I would show you what is in your book right now.
Okay. Can you repeat the numbers so I could copy them down?
Okay. Purpose of the trip. And then the B. For work, B equal to 0.5. For shopping goods, B equal to 2. For business, B equal to 2. For recreation, B equal to 2. For others, B equal to 2. But for social, B equal to 3. And shopping convenience good, we use B equal to 3. So mostly are 2, except the social and convenience good, which is 3. And then the work trip, which is 0.5.
Okay. Thank you. I got it.
All right then. Okay, now so that was the original gravity model. Now the newer gravity model, the formula is Tij is equal to the one you have in the book, Pi times Aj times Fij times Kij over the summation of Aj, Fij, Kij. J from 1 to n. Actually, this is the same formula as I just discussed, because PI is the same as OI. Sometimes they call it production, sometimes they call it originated trips. It's the same thing, production or originated trips. AJ is the same, attraction. Now, Fij that we have here, we will call that friction factor. Is a travel time factor, they call it friction factors. So all of these are called, okay? So okay, now the Fij is related to 1 over Tij to the power of n. So if you compare this with what we had before, we had this Cij. So Cij, we said it can be travel time, it can be distance, or it can be cost. So that's pretty much the same thing as Fij in the formula, because you are multiplying Pi times Aj divided by Cij. That's the same thing as dividing by Tij to the power of n. N is the number that we use as a b over there. We use n over here. The only thing that's different here is your Kij. You don't have Kij in the other formula. And that's called socioeconomic factor. Okay, and it can be any number. Most of the time, we assume Kij equal to 1. Why is that? If the zone that you have is uniform, that means if this residential area is all residential area here, and there is no problem. Kij equal to 1. But if you have a situation where you have a residential area here, and then you have a river going right here, and then there's an open space here, so it's not uniform. So Kij could be different. Or if you have a zone here that maybe Asian lives in this side of it, and Hispanic lives on this side of it. So again, socioeconomic variation is there. So Kij could be different. So that's when the Kij is not equal to 1, when it's not uniform. Okay? So that's the formula that we use. There's an example problem in your textbook that uses this formula. And let me see if I have a picture of it. It seems like I don't have a picture. Okay, what they have here, it's on page, okay, hold on. Okay, it's a problem on page 275. And that's the problem number 9-1. Okay, so what they do is they give you the, let me show you. So they give you a production, okay? They give you production of the, calculate the interzonal interchange due to 100 production at zone 1. So P1 is 100 trips at zone 1 with 250 attraction at zone 2 So zone 2, A2 is 250 trips. Okay. Attraction at zone 3 is 100. And then attraction at zone 4 is 600. So they gave you all the attractions and production. Assume the travel time factor from 1 to 2. So that means F sub 1, 2 is equal to 5 minutes. Okay. And then from 1 to 3 is equal to 10 minutes. And from 1 to 4 is 15 minutes. Okay. Assume that all Kij factors are equal to 1. Okay. Now they say calculate the values, okay, of the interchanges. Okay. They say calculate Fij values are often multiplied by an arbitrary constant in order that all the values are equal or greater than 1. Okay. So they give you that. Any question? Okay, so the way you can do this, you can put them into formula and calculate the way we did it. Okay, for instance, let's say I want to find the Tij, which is, let's say, T1, 2, because T1, 1 is 0, because there is no attraction in zone 1. Nobody go from 1 to 1, but they go from 1 to 2. So if you want to do that, from 1 to 2 is Pi is 100. You multiply by attractions of zone 2, which is what, 250. So that's the PIAJ. Time Fij. Now Fij, as I say, is 1 over Tij to the power of n, assuming n equal to 1. So Tij will be what? 1 over 5 minutes. So it's 20, correct? And then you multiply that by 100. Okay? So that's how you get it. So your Fij is 20. What would be your Kij? They said assume equal to 1. Over the summation. What would be the summation? Summation will be Aj, Fij, Kij. So how many J you have?
3.
3 of them, correct? So you will have Aj, which is 250, times Fij, which is 1 over 5, which is 20, correct? Now you have to get 1 over 10, okay? Which would be they gave you 5 minutes for Fi. Okay, they just gave you they gave you actually Fijs. They calculate for you. Okay, so what they did is that, no, they calculate the Fij for you. Let me just put those, they gave you the travel time, but then the N is different, so they gave you that. So here is the what they did. They gave you the Fij. So for FSA 1, 2, they gave you 20. They gave you for 1, 3, they gave you 5. For FSA 1, 4, and they gave you 2.22. They gave you those. Okay, so we're gonna use those. So that will be time 1. That's the first term, plus 8.3, which is 100 times F13, which is 5, times 1, plus A4, which is 600, times 2.22, times 1. Okay, so you calculate that. So your T12 will be the numerator will be 5,000. Okay. And then the denominator will be 6,832. So when you calculate that, you end up with 73.2. So out of 100, 73.2 of them going to the zone 2.
Professor, that's using the equation they have on the textbook, right? Not the one you wrote.
Exactly.
If you do the one you wrote, it will be almost the same way, right? Just instead of doing the 1 over.
But here, the only difference here is that they gave you the Kij in this formula, which we don't have it in the other formula.
Oh,
And then in this formula, we are assuming 1 anyway, so. Yeah. Okay. So you can do it this way. Then you can find T13, T14, and then when you add them up, it will be 100. Another way you can do it that your book did it, you can just tabulate it, which is the same thing, but they try to do it this way. So they put the zone here. Okay. So then they put your AJ, then they put Fij, and then they put AJ, Fij. Okay. Obviously, since it is assumed equal to, but this should be times Kj, because we are assuming Kj equal to 1. That's why they don't have a Kj there, but you should have that, because on the top numerator, you have AJ, Fij, Kij. All right, and then here you multiply AJ, Fij, and Kij, divide that by the summation of AJ, Fij, and Kij. And then you put a 100, so that will be your P, and then you will have your Tij. So they put into this tabular form. Okay, I will show you why they did that, which is the same thing, but so the first one is zone 1, zone 2, zone 3, and zone 4. So you know what your AJs are for each zone: 0, 250, 100, and then 600. So those are your AJ. The problem gave you that. Your FIJ was given also 0, 20, 5, and 2.22. So they gave you these two. So what they do by this tabular form, you just multiply the second column by third column, AJ, FIJ, and then KIJ equal to 1 anyway. So this will be 0. 20 times 250 will be 5,000. Correct? So actually this is 2 more here. 5,000. 5 times 100 is 500. 600 times 2.22 is 1332. Now that you multiply these two columns and you have it, if you add these together, because the denominator is summation of AJ, FIJ, KIJ. So if I add these three numbers plus the 0, you get 6,832. And what is this? This is the summation of AJ, FIJ, and KIJ, correct? Adding this column, give you that. Now it's easy because now all you have to do, you know what the AJ, FIJ, KIJ is, 0 divided by 6832. So this one will be 0. Now you divide 5,000 by 683.2. So you get 0.732. $500 divided by 6832, you get 0.073. And then you will have 0.0195. Or no, okay, so you got that. Now your P is all 100, correct? Because 100 trip has to be distributed. So if you multiply by 100 by the previous column, you end up with here is 0. You end up here 73, and then you here is 7 almost rounded up, and then you have here is 20, rounding it. So the total will be what? 100, correct? So that's the way you can do it. You can put those in the formula the way I show you at the beginning, or you can put it in a tabular form, which is this way. Whichever you prefer to do it is fine. This is good too. This is pretty organized. All right. Any question on this? So this is example 9-1. All right. Now you have a homework to do, which is using this gravity model to do the homework. Your homework is 9-2. This is the homework. It's at the end of your chapter, number 9-2. You have to do it. What that homework they tell you to do is, first of all, they made a mistake. There's an error there. They said use example 9-4. This is not example 9-4. This is example 9-1. So if you have your book, you have to correct that. That's 9-4 is 9-1 because this is the gravity model. They say use this example with all the numbers that's given. The only thing that they give you differently, they give you different KIJs. So you will have a different KIJs that you have to multiply. The rest of the numbers the same. So it's pretty easy. Instead of multiplying by 1, your problem give you what the K, for instance, 1, 2 is, what's the K, 1, 3 is, what's the K, 1, 4 is. So multiply those Ks by AJ, FIJs, and then the same thing with the denominators, that will, you add them up together, and then use that. Does everyone understand that?
Professor, is it on page 277 or what page is it?
That is at the end of your chapter, which is page, that's the page 293. And the problem say complete the assignment of interchange volume in example 9-3. That's not 9 dash, I'm sorry, that's not the one. Example, that's a problem number 9-2, as I mentioned. They said rework example 9-4. Correct them. That's a 9-1. Assuming the following socioeconomic characteristics adjustment factor. So K12, they gave you 85. K13, they give you 2. K14, they give you 1. So instead of using all of those equal to 1, use those. That's all you have to do. The rest of the numbers are the same. So just give you a little practice of how to do it.
Professor, how do we solve for Fij again?
No, you're solving it for TIJs. So
Oh, yeah,
these are
but how do we get a Fij?
FIJ is given to you.
Well, you solved for it earlier. I
No.
just want to know how you solved for it.
Okay, I thought that's what they did, but no. If you remember, I said the Fij is equal to, I said it's equal to 1 over Tij to the power of n, correct?
Yeah.
Now that n, we don't know what it is in this problem.
Oh, okay, okay.
So if you knew that, you could do that.
Okay.
But
that makes
since we
sense.
don't know, I thought that that's how they did it, but the rest of the number doesn't match that. So they just gave you the Fij in this case. If they don't give you, if they give you only Fij equal to, if they give you the travel time, you can put it there, but then you have to know what the n is.
Okay, sounds good. Thank you.
Yeah. All right. Any other question? So your homework problem is pretty easy. All you do is that in this here, they, instead of using Kij equal to 1, you just use what they gave it to you in the problem. And the same thing here, and the same thing here. That's the only difference. And sometimes in the problem, what they do is give you this way, instead of giving you the Fijs, so instead of giving you the Fij, they give you the graph. They said here is this is the Fij, and this is the Tij. They give you the travel time between the zones, and they give you a graph like this. So what you do is that you take that Tij that they give you in the problem, and then try to find what the Fij is from the graph. So you read that, and then you use those. So you know what the travel time is, so you use all these different, numbers for your Fij. Sometimes in the problem, they give you the graph that you have to put your travel time, and then you find the Fij. Any other question? So that's pretty much the gravity model, how you do it. Now, to find the Fij, so if they ask you that, what do we mean by calibrating a gravity model? Okay, that's the question sometimes I ask even on the exam. You remember we said about calibrating or estimating regression equations? And we said to find the unknown. And here, if they say, what do we mean by calibrating gravity model? Means that finding the unknown. What is unknown? Because pretty much we know how many trips is produced or attracted. Where do we get those? We get it from trip generation model, which we discussed before. So the travel time is given. Now, we don't know what the Fij and Kijs are. So if they say, what do we mean by calibrating or estimating gravity model? You have to say estimating Fij and Kij. That's what it means. That's how we have to do it. Now, how do we calibrate the gravity model? All right. So I have to give you an example of how we do that.